Alright, and welcome to another quick programming tutorial. In this video, we're going to talk about the logic of looping activities. Loops basically break down into two different types. We have condition-controlled looping and counter-controlled loops. We'll focus on condition-controlled loops first. I'm going to talk exclusively about the while loop. There is a secondary condition-controlled loop called the do-while loop. The main difference between the two is when the condition is checked. A while loop is a precondition loop, which means you have to check the condition before entering the loop body. The do-while loop is a post-condition loop in which you would check the condition after the loop body runs at least once to see if you should do it again. Now, there's no huge advantage to the do-while loop other than the fact that you are forced to do the loop body once, and no matter what kind of, if you're going to use a do-while loop, there's no reason you can't run it also with a while loop to write it carefully. So we're going to focus just on the while loop, and our counter-controlled loop is going to be the for loop exclusively. So first let's start with the while loop. There are three rules you have to basically live by when it comes to these condition-controlled loops. You need some sort of control variable, and you need it initialized, something that you can use in your condition statement in step 2 to test against to see if your condition will be true or false. Once you've got that control variable set up and the condition set up with your while loop heading, somewhere inside your loop body you have to make an adjustment, an incrementation, or an update to that control variable. Otherwise you get stuck in what we call an infinite loop because you have no way to get out of it without some special case structure or break statement or something like that. So we're going to write a loop that will display multiples of 10 up to 1,000. So all in all, I'm not going to go through the whole pseudocode setup where there's the start and the declarations and things like that. We're just going to talk about the loop exclusively. So we'll talk about those three things. The first thing I would need is that control variable. So I might say something like set value equal to 10, because that's going to be the first multiple of 10. And then the while loop sets up with the while keyword, and then you must throw in some sort of condition, and that condition should be based on that control variable that you have here. So value is less than, say, 1,000. Now in that loop, I don't need a then statement because there's not like a condition like an if-else sort of bit. But what I want to do is maybe say display the value, and then I need to change, increment, or update the control variable, and what we're going to do here is just set value equal to the value increased by 10. And so in this little brief tutorial, I've done all three of those parts. I have my control variable, value, I have my condition, along with my while loop heading. I'm doing something in the loop, so again the indentation shows the loop body. I can see that both of these statements are in the loop body. They're going to happen over and over and over again. And somewhere in the loop I have the incrementation or update to my control variable. Now these two lines of code are going to continue to run until value finally exceeds 1,000. So once it reaches 1,010, this is no longer true, which means my loop no longer runs. And that's essentially how they work. It keeps going and going and going until eventually this becomes false. And that's why it's important to have that third step in there where you change the control variable each and every time. All right, let's do something a little bit more problematic, a little bit more robust. So let's write a loop that will display a math problem and ask for answers until we answer correctly. So a true condition. I don't know how long this is going to run, whereas in the other loop it was kind of counter-controlled. We knew exactly how many times it would run. In this one we don't because it's up to the user. So I may have something like input value 1, I might input value 2, okay? So I'm putting through things in, and my goal is to come up with the sum. So let's let the computer decide what it's going to be. We'll say set sum equal to value 1 plus value 2. So the computer knows what the sum is, but now I'm going to input some sort of answer for value 1 and value 2. So input answer, and that answer will be prompt something for the sum of value 1 and value 2. So again, my idea here is I type in two values, or I'm given two values. Maybe they're done randomly. Maybe I don't even input them, but for the time being, we'll just say input. And then I want to be able to input the sum of the two values. So I put in 5 and 7. I should be able to put in a 12, and that would be the sum. And I want to keep inputting answers until I get it right. So notice I have my value primed here with something to go in, and while my answer is not equal to value 1 plus value 2, I want to keep getting new answers, and so I might display something like incorrect, and then get a new answer, so we might input answer again. And then finally, when I'm out of the loop, notice my indentation goes back to the left. I might display correct. So there's some easy pseudocode. Okay. So again, this isn't meant to be a full-fledged program, just demonstrating the loop, but you can see I've got all three parts. I have my control variable, I have it primed through input. I have my condition, while my answer is not equal to the sum of value 1 and value 2, or not equal to, I should say, sum here, I could say that as well. Didn't have to get this, I could work with it. And then I display it's incorrect, I input a new answer, and again, here's my update to that. So I've got my answer getting updated, which means eventually, hopefully I type in something correct. I need to, or otherwise this loop will never end. And as soon as it does, I can display that I got it correct all the way through. So that kind of does it for condition controlled, and there's really not much to it. You just have to set up those control variables and have some sort of condition to keep looping upon, and while you're within that loop, update the control variable for yourself. Okay? All right, let's talk about counter-controlled loops. Counter-controlled loops are a little bit different. They're always going to be done a specific number of times. Now that number of time could vary based upon user input, but we should know by the time we get to the loop exactly how many times it's going to run. Like in this particular example up here, I have no idea how many times that loop's going to run, or if it's going to run at all. It may not even run. But a counter-controlled loop, by the time I get there, I should know exactly how many times it's going to run. So let's get through a question like this, displaying all the perfect squares from 1 to 100. Well, in here, maybe I'll make a quick declaration. We'll go declare, we'll do an integer for a counter. Usually you'll have a counter, and then we'll declare something called squares, just so that we can keep track of all the squares of our counter. Now, a counter-controlled loop usually starts with the keyword for, and then we will say what our control variable is. In our case, it's counter, and we will set it equal to something. Let's set it equal to 1, and we're going to run all the way up to 10. Right, so I can see how far it's going to go. And inside that loop, I'm going to set my square value equal to counter times counter, or you could say something like counter squared. Okay, or if you're not comfortable with that notation, times counter, doesn't make a difference. And then I want to display it. And that's all there is to it. Now, this could be done with a while loop, with the condition controlled loop as well. But the fact of the matter is, this nice heading, this for loop heading, takes care of 3 of those steps for me in one shot. It has the control variable initialized to something. I know how long I'm going to use it for with the 2. And I know where I'm going to stop. I'm going to stop at 10, so it takes care of all that stuff for me. And I know it's also going to increment by 1 because I kind of left it blank, and it's assumed that it's going to increment by 1 each time. Now, if you need to increment by something other than 1, let's say you needed to count backwards, or let's say you needed to count multiples of 3. Okay? Again, that's pretty easy. We can declare an integer called counter again. And then I might say something like for counter equals 3, because that's the first multiple of 3, and I want to go to 99 because that would be the last multiple of 3 before 100. So let's say we just want to do multiples 3 up to 100. But I might say something like this, step 3, and that will allow me to go from 3 to 6 to 9 to 12 to 15, so on and so forth. And now it's just a matter of displaying the counter. Okay. And that's essentially it. Right? That takes care of all of the conditions for me. It takes care of the incrementation for me. It tells me when to begin and where to stop. So setting up a for loop, a counter-controlled loop in pseudocode can be done really, really quickly and really, really easily. If you needed to count backwards, make that step negative. Make it a -1. Make it a -10 if you want. It doesn't really make a difference. But it's always generally in addition to what you want to do, because we want to count from one to the next to the next. There are different ways to do that in different programming languages, but most of those, if you were to pseudocode them, then you would code them with a while loop instead. But then you can bring them into your coded platform as if it was a for loop. So either way, both techniques work very, very well. Obviously, the while loop is kind of a jack of all trades. It can take care of anything and everything for you, while the for loop is very specific in how it works and what it counts. When we get into actually coding in Python, you'll see that the for loop in Python is more of a sequence-controlled loop, but we'll talk more about that when we start talking about sequences along those lines. So that's it for this tutorial. Hopefully that works out for you, and in the next one we will talk about how to deal with flowcharts and things of that when we talk about selection and iteration.